So this is the problem set on 6.2 trig. Yeah, you can't really read that, but that says trig. And we're going to start with number, let's just look at number 15. Tangent square x plus 3 equals 0. Okay? And that is actually going to be tangent squared of x equals negative 3 when we move the negative 3 to the other side. And what we have here is actually, if it helps to write it this way, you can go ahead and do that. Sometimes it helps to do that. Square root. So you have tangent of x equals the square root of negative 3. What do we get when we have a negative 3 under the radical? We have an imaginary number, which means there is no answer to that. So that is the null set. Alright, so this is number 21. Let's get all of our signs together. In fact, let's take this one on the left and move it over here because we can get that negative then to be a positive. So we're going to have 2 sine squared x, we'll make that 0 over there, plus 3 sine x plus 1. So we have got, basically if you look at this as your x is your variable, it would really look like this. So you're doing the math for an equation that looks just like that. And you can take that and break that into two binomials here. And those two binomials are going to be 2x and x. And we've got, what, a plus 1 and a plus 1 there. So now let's put sine x back in there for x. So we're going to get 2 sine of x plus 1. Now see, I just use, the book doesn't do this, and if it's more confusing than it's worth, don't do it. But it's just easier for me to make this sine of x a variable x and come up with this and solve it and then plug the sine of x back into it, because golly, that sine of x just gets me all whipper-jawed. It makes it really hard for me to do the math. But this way, I can get an answer like that and then rewrite it as equal to 0, which means that one of these parentheses is going to have to equal 0, so when I multiply it by the other one, I get 0. So either 2 sine of x plus 1 equals 0, or the sine of x plus 1 equals 0. So one of those two has to be true. Alright, and then I'm going to divide by 2, so I get the sine of x equals negative 1/2, or sine of x equals negative 1. So those are my two options. When I look at, let's see if we can move this all up, just bits and pieces at a time. Let's move all this up, because this is 0 here, I don't care about it. All I'm interested in is this here and this here. Alright, let's look at the sine of negative 1/2. The sine of negative 1/2 is going to have two solutions. I get a negative answer, all students, in this quadrant or this quadrant. I get a sine of negative 1/2. And a 1/2 is a 30-degree angle. So I know I'm going to get a 30-degree angle here and a 30-degree angle there. So that means that I'm going to be at 180 plus 30, which is going to be 6 pi over 6, 7 pi over 6 will be this one here. And again, the way I got that is it's a 30-degree angle. 30-degree angles are pi's. There are 1, 2, 3, 4, 5, 6 30-degree angles in 1 pi. So that would be 6 pi's over 6's. And then I'm one more, so 7 pi over 6. 8, 9, 10, 11. So this one's going to be 11 pi over 6. Alright, so sine of x equals -1. It's going to be in the same quadrants there. So let's see, my solution set for sine of -1. When is sine negative? In the third quadrant and the fourth quadrant. Okay, so we've got sine of x is -1. This is opposite over hypotenuse. The hypotenuse is always positive, so I'm going to have an angle here where my opposite is going to be -1. And if I have it 1 here, my opposite over here is going to be -1. And my hypotenuse is going to have to be 1, right? Because in order to get -1, it's going to have to be -1 over 1, or, you know, a number over itself. So I know that I'm going to be in 3 or 4. So what angle is this? So first of all, I need to find this angle and this angle. And then I'm going to take this angle and add it to 180 to get all the way around to here. So I get this. And then I'm going to take this angle all the way around to there. And I'll leave that up to you to find that. For one like number 35, where we have 9 sine squared theta minus 6 sine theta equals 1. We're going to write that with everything on the same side. So instead of having that equal 1, we'll make it -1 equals 0. And then you're going to use quadratic formula, a, b, and c there. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And once you do that, you'll end up getting the sine of theta, which is our x value. Our sine of theta, you'll end up getting 1 plus or minus the square root of 2 all over 3. And I'll leave that up to you to do that quadratic formula. So we get two angles. We get an angle in quadrant 1, and we get an angle in quadrant 2. For the sine of theta equals 1 plus the square root of 2 over 3. Now that's a plus or minus. So if we have the sine of theta equals 1 minus the square root of 2 over 3, now my sine is going to be, this number here is going to be negative. It's going to be smaller than 0. So therefore, these angles will be in quadrant 1 and 2, and these will be negative, so these are in quadrant 3 and 4. So we're going to get 4 different angles in 4 different quadrants there. So, sine of theta when it's plus, sine of theta when it's the minus part. So then use a calculator to go ahead and take 1 plus the square root of 2 divided by 3, and then take the arc sine. Okay? And that will give you the angle for that one. And do the same thing over here, and that'll give you the angle for that one. So when you do this the first time, you should get like 53.6, it looks like, for your first angle. So that would be an angle like right here. But then you've got this angle. So then you're going to have to measure that one. And that should be about 126.4. And then you're going to have this one here you're going to plug in, and you're going to get an angle here and an angle there. So I need all 4 of those angles then for that problem. So that's pretty much the way the rest of these are, and it is going to take practice to get these down. They're not easy problems to do, but just keep working on them, and slowly you'll start getting it.